In composition of functions, what we are doing is taking two functions, usually f and g, and we are combining them in some way to create a new function. So yesterday we added, subtracted, multiplied, and divide f and g to make a new function. Today we are going to actually plug one function into another to create a new function. So a real-world example of this. We're actually going to do a real-world example of this in our notes, but say you go to a store and they have a 20% off deal on all of their clothes. You also have a $50 off coupon. So the stores usually figure this out to see which is more beneficial to them and not to you, but the thought is, should you use the percent off deal first and then take $50 off, or should you take $50 off, then use the percent off deal? So that is the composition of functions, actually doing something and then doing something else to it. So we are going to find f of g of x. This thing says f of g of x. So f parentheses g parentheses x means f of g of x. It means we are going to take the g function and plug it into the f function. It's basically substitution. So I'm going to use colors as much as possible to help you see this. Our f function is 3x. Our g function is 2x minus 6. They want us to do f of g of x. Okay, this means I'm going to take my f function. My f function is 3x. Instead of the x, I'm going to put parentheses. We're going to take 2x minus 6 and put it in place of that x. So instead of the x in the f function, we are going to substitute 2x minus 6 in its place. We are taking the entire g function and putting it into the x of the f function. Now we just need to simplify. How would we simplify this function? Distribute. 3 times 2x is 6x, and 3 times 6 is 18. F of g of x is 6x minus 18. Okay, I'm going to create a new number 10 because I don't like this number 10. So f of x is going to be, I'll use my pretty colors too. F of x is going to be 5x plus 2. G of x is going to equal x minus 7. Find f of g of x. And I try to write it a little bit more spread out so that it doesn't look so confusing. I don't want it to look like a big mashup of letters. I want you to see we're taking the g of x function and plugging it into the f function. So our f function is 5x plus 2. So 5 parentheses plus 2. Instead of that x, I am going to take my entire g function and put it in place of that x. So the x minus 7 goes in place of the x in the f function. Now we need to simplify. So distribute 5x minus 35. And we still have the plus 2 from up above. Combine like terms, we have 5x minus 33. So f of g of x is 5x minus 33. Because we are creating a new function, we have to think about what is the domain of this new function. In our f function, we can use whatever numbers we want. In our g function, we can use whatever numbers we want. But when we combine those two functions in a way to create a new function, we have to think about, are there any restrictions? So some things to look for. First, check your denominators. If you end up with a denominator a denominator cannot equal 0. So you may have to do some sort of restriction, like x cannot equal whatever number it would be that would make your denominator equal to 0. So if your denominator said x minus 2, then x can't be positive 2. If your denominator is 5x, 5 times x, then your restriction would be x can't equal 0. The other thing you need to look for is even roots, like square roots, fourth roots, etc., or x to the 1/2, x to the 1/4, etc. If you have an even root or an even denominator rational exponent, your restriction would be x is greater than or equal to 0. That basically says that you can only use positive numbers. We are going to do whichever function operation it says, and then we are also going to think about what the domain of our new function would be. The first one, this is the first time you've seen this, f of x. F of x means we are going to take the f of x function, x to the third, and plug it into the x of the f function, x to the third. So we're going to plug the function into itself. It kind of creates a black hole, but not really. We're not dividing by 0, so we're not all going to be engulfed by an awful black hole. But our f function is x to the third. So when I look at this, first I'm going to, oops, not green. First I'm going to rewrite it this way. F of x. To kind of show myself like the hole that I'm plugging things into. So our f function is x to the third. So I'm going to put parentheses to the third. Does everyone agree that our f function is something raised to the third? We are going to plug the f function into that. So we are going to put x to the third inside our f function. Now we need to simplify. If there's parentheses with exponents, what do we do with the exponents? Multiply them. X to the third is x to the 9th. Now, domain. Can you raise positive numbers to the 9th? Yeah. Negative numbers to the 9th? Yeah. 0 to the 9th? Yeah. And if you ever wonder, I don't know if I can or not, grab your calculator, try positive 2 to the 9th, 0 to the 9th, negative 2 to the 9th. If your calculator allows you to do all of them, then it's fine. Your domain is all real numbers. Number 12, we are simply adding the two functions. So we've got x to the third plus, will you please stop moving around, computer? Our g of x function is x plus 4. Is there any simplifying that we have to do with that one? No. Are there any restrictions? No. You can do positives, negatives, 0, everything's fine. So our domain is all real numbers. Your domain is usually all real numbers. There are only a few times that you have to do some sort of domain restriction. Number 13 is a classic domain restriction problem because we are dividing. Our f of x function is x to the third divided by our g of x function, x plus 4. If there's addition in the denominator or in the numerator, you can't simplify the x's. So I know it's x to the third over x, but because that x on the bottom is x plus 4, you can't simplify the x's. It's stuck. It's like x plus 4 is in parentheses. But we do need to think about a domain restriction. If our denominator is x plus 4, what x value would make that denominator equal 0? Negative 4. So we have to say x cannot equal negative 4. So in this new function, you are restricted to all x values that are not negative 4. All right, I want you to try 14 on your own. It's g of f of x. So notice this is backwards from what we have been doing. You need to take your f function and plug it into your g function. So try number 14 on your own. If this is confusing for you, using colors can definitely help you. So my g function is green, my f function is blue. I'm taking my blue function and plugging it into the green function. So my green function is something plus 4. I just put parentheses instead of the x. My f function is x to the third. That's what I'm plugging into my green function. Now, simplification. There's really nothing to do. Our final answer is x cubed plus 4. There's no restrictions. The domain would be all real numbers. In this next part, they give us an f function, they give us a g function, and they're asking us to evaluate f of g of -3. You're going to start in the middle and work your way out. This means take -3 and plug it into the g function, get your answer, and then plug that answer into the f function. So we are going to do g of -3 because that's what's in the middle. So we're taking our g function, and instead of x, we are going to put -3 in place of the x. What is 5 times -3 plus 1? See, -15 plus 1 would be -14. Oops, I don't want purple. I want green. Okay. Once you have the result from taking g of -3, now you're going to do f of that answer. So f of -14. Our f function is 2x squared minus 7. We are going to put the result of that g function inside our f function. And this one you'll probably going to need a calculator for. The next one is g of f of 2. This means take 2, plug it into the f function, get your answer. Take that answer, plug it into your g function. Take a moment and see if you can do this one on your own. Okay, so this time we're plugging it into the f function first, because if you look at the original problem, it says g of f of 2. Start in the middle, take the 2, plug it into the f function. We get 1 as our answer. You then plug that 1 into the g function and end up getting 6 as your final answer. Okay, so f of -5. We take -5, plug it into the f function. -5 squared is 25. 25 times 2 is 50, and 50 minus 7 is 43. We then have to plug that into the f function again. And this is where I'm going to need some calculator help. 2 times 43 squared minus 7, 3,691. So number 1 is saying, use function notation to describe your cost, f of x, of using only your $150 off coupon. So the TV costs X dollars. We are going to deduct $150 from that price. So your f of x function is x minus 150. Next, find the g of x function using only the 30% discount. Now I want you to think about a 30% discount. That means you get 30% off the price of the TV. So if you are not paying for 30% of the TV, what percent of the TV are you paying for? 70%. So this would be 0.7 times x. If it's 30% off, that means you're actually paying for 70% of the TV. Number 3 is basically asking you to take those two functions and do g of f of x. Use your $150 off coupon first, then take 70% off of that total. Number 4 is asking you to do the reverse, f of g of x, to see which one is actually the better deal. And in your assignment, you're going to be asked to do this. If you